Hello, FireTech 106 students. This is going to be our second part of our portable fire extinguishers lecture, which is chapter 9 in our textbook. And we're going to be covering sections 5 through 6. And that's going to correspond with page 252 to 265 in your textbook. And we're going to start here at slide 64 and go through slide 121, which takes us through the rest of the chapter. Okay. So we'll go ahead and get started with this lecture, and this will be the second part of our portable fire extinguishers section, which is our last module before we move into the final. So extinguishers may be distributed properly throughout a facility to ensure they are available during an emergency. So they want to be located in close proximity to where they're going to be needed. You can't be effective if there are not enough to provide for the hazard that we have involved. So they have to be suitable for the hazard and the amount of hazard that we have. Our requirements that we find for our distribution. We're going to look at NFPA 10, and those are going to be in our separate classes, which are our class A, B, C, D, and K. All right. So our ordinary combustibles, our flammable liquids and gases, our electrical fires, our combustible metals, and then also our cooking and fat oil fires. We're going to have local codes and ordinances. So if you work for a city, they may have more restrictive codes, but those codes will want to be reviewed along with our NFPA 10 requirements. There are many important elements in selecting and distributing the portable extinguishers. So what are the chemical and physical characteristics of the products that are going to be combustible that might be ignited? So what are we storing? What's in this building? What's in this facility? What's in this structure that could ignite and catch fire? What is the size, the severity? How intense is that fire going to be? And then how fast can that fire go through those stages of fire and advance into from that incipient stage to that fully free burning or fully involved stage? Where are extinguishers located? The effectiveness of those extinguishers on the actual hazard itself. And then who's available to operate the extinguisher? Are they trained? Are they not trained? Do they have any physical limitations? Do they have the physical capabilities of using those fire extinguishers? The environmental conditions that may affect the use of the extinguisher. Are there wind conditions? Are there temperature conditions? What could cause problems with using those extinguishers? And then are there any adverse chemical reactions between the extinguishing agent that you have and the burning material? Is it water and you have a burning metal, which is not going to be good? Is it electrical and you have water, which is a conductor? So those are also issues that you want to take a look at. And then are there any health and occupational safety concerns that go along with it? And are these extinguishers inspected and serviced regularly? And is there any requirement to maintain those extinguishers? There's a requirement for all of those extinguishers. And your fire prevention division or bureau should be fully aware of those, as should the building owner or occupants. There are many factors to consider when determining extinguisher distribution and size. The type, size, and number of extinguishers needed may vary according to the type of the occupancy and the nature of the hazard. NFPA 10, that discusses extinguisher selection based upon the nature of the hazard and the size of the extinguisher. The general method is used to determine a safety distribution or satisfactory distribution of extinguishers in the vast majority of these situations. And then classifies the occupancies as, is it a light hazard, an ordinary hazard, an extra, or a high hazard? So how much hazard does that occupancy actually have? And distribution is specified on the basis of that classification. NFPA 10 recommends the minimum size of extinguisher and the maximum area that extinguisher is going to be able to protect. And then you have tables that provide information for the computation of how much square footage of a facility that it could be put out, coupled with the size of the extinguisher that's required for that square footage of the facility, and the minimum number of extinguishers that you have to have installed so that you take into account the square footage of that building. Tables take into account the hazard classification of the facility as well. Is it a light hazard? Is it an extra hazard? So that will also help determine how many extinguishers you need and what size you need. In some situations, several lower rated Class A extinguishers may take the place of a higher rated one. 2 or more extinguishers may be used to satisfy a 6A rating if there are enough trained individuals to use them. When the extinguisher weight causes problems for those who will be operating it, 2 extinguishers of lesser weight may replace heavier extinguishers, so that way the occupants are able to use them. Class B fires, they present unique fire control challenges, situations that may be encountered when providing for Class B extinguishers for Class B hazards. So spill fire, where the flammable liquid lacks depth. Flammable liquid fires where the liquid has depth. Okay, so is it a spill, or is it got a lot of depth and a lot of volume to the actual product that's being spilled? And FPA 10 establishes 1/4 inch as a criterion for flammable liquid fires to be classified as having depth. So it has to have at least 1/4 inch of volume to have depth. Distribution of extinguishers for Class C and D fires differs from the other classes of fire. Class C, there's no special spacing rules because this usually will involve a Class A or Class B fuel, but it's energized. So once it's no longer energized, then it's generally going to be a Class A or Class B fire. Class D, your placement and distribution of extinguishers for combustible metals cannot be generalized. The placement's going to involve the specific metal and the properties of that specific metal, how much metal is present, and whether that metal is solid or if it's particulate, and how it can be dispersed, and then what are the characteristics of the extinguishing agent that you're going to use on that fire itself. And FPA 10 assigns more restrictive distance requirements for the distribution of Class K. So the potential for a hostile fire is always present in your commercial cooking occupancies. Employees are charged with maintaining appropriate cooking temperatures, and the maximum travel distance from your hazard to an extinguisher is going to be 30 feet. All right, so you're going to have your system, but you also have a maximum travel distance to reach that extinguisher of 30 feet. So it's got to be mounted somewhere that's visible within 30 feet of your deep fryer or whatever your wherever your cooking hazard is going to be. The process for installation and placement of portable fire extinguishers. In order to be effective, extinguishers must be properly placed and accessible. So one, you're mounting them so that you can avoid damage. A lot of times they're going to be placed in wall cabinets or wall recesses. So you'll have a cabinet here where you're going to have an inlet in the wall where it's recessed, and you're going to have your extinguisher there. If the cabinet is placed in a rated wall, the cabinet must have the same fire rating as the wall so that it protects that fire from impinging on whatever is inside of that wall. Installation and placement, it has to be visible, has to have the appropriate signage, you can't block it. It needs to be near points of egress or ingress, where you're coming in or where you're going out, and it has to be near normal paths of travel. Extinguishers must be placed at the proper height so that they are accessible to everyone. So it's got a 5-foot maximum for extinguishers less than 40 pounds, 3.5-foot maximum for extinguishers that are greater than 40 pounds, and then it has to be 4 inches minimum above the ground. Okay. The physical environment where an extinguisher is placed is also important to its reliability. So temperature, corrosive fumes, snow, rain, all of those things can impact the extinguisher. So the extinguisher must be placed in a suitable position so that we know, or a suitable place so that we know it's going to be functional. Tampering can affect the extinguisher's ability to operate properly. So colleges and public facilities, they usually are vulnerable to vandalism. Don't need to get into that too much. But then commercial products available to limit the extinguisher tampering or removal, right? Like the cases or the cabinets that you have. But again, they can't be so tamper or removal proof that you can't access them easily so that you can use them to extinguish the fire. Certain identified criteria for portable fire extinguishers carry on fire apparatus. Extinguishers carried on apparatus have special requirements. So they're subjected to harsher use than those in the private industry. They should be carried in compartments. You see these here. These are in a compartment and they're mounted rather than being exposed to the exterior. We used to carry them on the exterior bumper. Now they're actually in their own cabinet for us. Requirements for extinguishers on an apparatus. Your NFPA 1901 requires a portable Class A, Class B, and Class C extinguishers. NFPA 1901 does not require Class K extinguishers on an apparatus, so you don't have to have that. Individual extinguishers specified by the apparatus purchaser. So when we purchase our rigs, we spec them out, and then we get the equipment that's fitted to go into our rigs. Minimum rating for extinguishers on apparatus: 1 dry chem rated for BC fires with at least an 80 BC rating, and then 1 2.5 gallon or larger water extinguisher, or what we would call pump can. Explain the inspection, maintenance, and recharging procedures for portable extinguishers. Fire extinguishers must be inspected regularly to ensure that they are properly placed and in working order. So you see the tag on there. He's doing a visual inspection of the extinguisher for damage, but also inspecting the tag. Your visual check. Your visual check is going to include: is it placed properly? Is it fully charged? You should be able to see that on the dial. Is it blocked? Or is it tampered with? Or is it empty? Right? Inspection importance. Extinguishers are used infrequently. So extinguisher that does not properly operate can result in property loss or personal injury. If you go to grab one, it's not charged, hasn't been inspected, it's not full, then it's pretty much useless. It is important to conduct extinguisher inspections frequently and maintain complete inspection records. Items to check during your monthly inspection is the location, the access, visible and accessible, inspection tag, the horn or nozzle, the lock pins and tamper seals, signs of physical damage, your pressure gauge to make sure that it's pressure. If you look at this gauge here, it's in the green, so that means it's good. Applicability of the extinguisher for hazard classification. Is it the same classification of extinguisher as it is for the hazard that's on the premise? Extinguishers must be maintained to ensure they will operate safely. They must be performed by a certified service technician. A thorough examination of mechanical parts, extinguishing agent, and expelling means should be performed as required by all your applicable codes and standards for your city or your jurisdiction or the authority having jurisdiction. Non-rechargeable extinguishers, they need to be removed 12 years after the date of manufacture, and then you purchase new ones and put them back in their place. And if you need any information about the maintenance intervals, you can go ahead and look at NFPA 10. Extinguishers must be recharged to replace the expellant and the agent if it's necessary. It's not required on a periodic basis for every type. Recharging some types of extinguishers may need pressurization, so that must be performed by a properly trained technician with proper equipment. Too much pressure makes the cylinder dangerous because you're overpressurizing a cylinder. Important to use a source of expellant gas with pressure not greater than 25 psi above the operating pressure. And then moisture that gets into non-water extinguishers is potentially dangerous. All right, so if they're non-water extinguishers, we don't want moisture to get in there, right? Hence the fact that they're non-water extinguishers. Only use chemicals or materials specified by the manufacturer or materials with an equivalent composition. Hydrostatic testing procedures for portable fire extinguishers. So agent storage cylinders, the discharge hose, and the discharge nozzles are required to pass a hydrostatic test. The test consists of pressurizing components to 5 times the rated capacity for a period of not less than 5 seconds. Extinguishers are considered pressurized vessels with the exception of a pump tank, water extinguishers, or pump can, right? Physical damage and corrosion can cause the extinguisher shell to fail. Extinguishers must be tested to ensure it is strong enough to withstand pressures with which it's going to be subjected, and then tested by filling the cylinder with water and applying appropriate pressure with a pump. Performed at intervals specified in NFPA 10 or whenever there is evidence of damage or corrosion. Should only be performed by a trained and experienced professional. or personnel, test pressure based on extinguishers service pressure and factory test pressure, and then carbon dioxide or CO2 extinguishers, and CO2 or nitrogen cylinders used as expellant source. The test pressure is going to be 5/3 or 167% of the service pressure. Factory test pressure is the pressure at which the vessel was tested at the time that it was manufactured. Extinguishers with certain defects or exposures should not be hydrostatically tested, and they should be removed from service. So this one here, you see that has a dent, that needs to be removed from service and needs to be replaced. Extinguishers that show signs of physical defect, such as damaged threads, corrosion, or welded repairs, those are not good. You need to take those out of service and replace them. Certain extinguisher vessels that have been burned in a fire, those also need to be removed and taken out of service, because you could have solder or riveted brass or copper, stainless steel shell that has contained calcium chloride. And then if a extinguisher fails a hydrostatics test, it needs to be removed from service, made inoperable, and then it needs to be sent to be destroyed. You don't want to try to fix that and put it back in service. Records of extinguisher maintenance and testing are important parts of the fire protection program. Plastic color tag records the maintenance that included the disassembly. Secured to the neck of the extinguisher handle or its hardware includes month and year of maintenance, and then also the name of the person who performed the maintenance. Hydrostatic test results recorded on the exterior of the shell, and then a record-keeping system needs to be established. General techniques for the use of portable fire extinguishers on different classes of fire. The most important factor in the effectiveness of the fire extinguisher is the person that's using it. One person may be able to extinguish a fire, and another person may not be able to extinguish that same fire. Right? Many extinguishers, they completely discharge the extinguishing agent in 8 to 15 seconds. So you don't have a lot of time to practice. Right? You have to understand how these extinguishers are used and just get a little bit of training on them. So improper use can injure the operator, and it also can delay extinguishment, causing that fire to grow. Immediately after discovery of a fire, the alarm should be activated and the fire agency should be notified. Commercial industrial occupancy, pull the fire alarm, use the voice paging system to activate an emergency response team. Smaller environment, immediately call the emergency number to summon the fire agency. So they're going to call 911. It is important for the extinguisher operator to choose the appropriate extinguisher for the type of fire. Use the picture symbol, the letter symbol identification methods. That will provide you a quick means of matching the extinguisher to what type of fire you have. If you choose the wrong extinguisher, as we've talked about throughout the last couple of lectures, right, it could be bad because it could have devastating effects on the actual material with the reactions. Then in many situations, extinguishers have been selected for the hazard present in the area or the facility, so the extinguisher matches what hazards they have at that facility or in that area. Individuals should be encouraged to verify that they have the proper extinguisher before using it. Don't want to just grab it and start using it without making sure that you're using the right extinguisher for the right hazard. The pass method. This is generally the steps that apply to all extinguishers. There are also specific techniques that apply to the use of extinguishers on specific classifications of fires. So the pass, that's going to be pull, aim, squeeze, and sweep. You're going to pull the pin, you're going to aim the nozzle, you're going to squeeze the handle, and then you're going to sweep, right? You want to hit that base of that fire as you're approaching it. After the fire is extinguished, the extinguisher operator should safely back away from the fire. Always maintain contact with the fire's location. Always have that extinguisher nozzle pointed at that fire. And then have a means of exit from the fire area. Be prepared to leave that area if you're not making progress on getting that fire knocked down, or if fire grows or the conditions deteriorate. While the pass method is appropriate for most extinguishers, some differences exist in fire attack depending on the extinguishing agent and the type of fire or the classification of that fire. Water-based extinguishers can be used on Class A materials. So the stream must be aimed at the seat of the fire. Initially used at a distance of 10 to 30 feet from the fire. Move closer to wet down smoldering materials after the flames have been knocked down. And fires involving compact or deep-seated burning materials must be soaked and pulled apart to reach the remaining fire. Foam type and multi-purpose dry chem extinguishers can also be used on Class A materials. Foam type extinguishers, AFFF or other types, it's used similarly to your water extinguishers. The agents have a low surface tension which allow it to penetrate into that tightly packed fuel. And then multi-purpose dry chem, the fire should be attacked at its base while sweeping the nozzle from side to side. This is going to put a coating over that fire, but it's important that you thoroughly coat all of that fuel surface because you want to provide that barrier for it to reignite. Do not inhale the dry chem agent that is dispersed into the atmosphere. It could irritate your respiratory system. Dry chem extinguishers are used to extinguish fires involving flammable, combustible liquids and gases. The agent should be discharged from a distance of approximately 10 feet. Flammable liquid fires should be attacked by sweeping slightly beyond either edge from a low angle, and be prepared for the fire to flash back across the surface of the liquid. If a second attack is necessary, it must be done with a full extinguisher. So you're just going to expel the whole extinguisher over that area. This is a pan of fire over here. It's a pan of a flammable liquid on fire, so you're going to go all the way across. Try and put that coating over the top. If you need to use a second extinguisher, get a second full extinguisher and come back and do it again. Carbon dioxide extinguishers are also effective on flammable liquids. The CO2 must be applied at closer range than other agents. Sweep it across the surface to overlap the burning liquid. It has a cooling and a smothering effect. Continue to discharge after the initial extinguishment to cool the fuel and prevent that from reignition or flashback. Then your AFFF is effective on Class B fires involving hydrocarbons, such as fuel oils, gasoline, and kerosene. Effectiveness. Without an AR rating, it's not effective on flammable liquids like acetone, alcohols, ethers, lacquer thinners, because those will dissolve the foam and then render it useless. So it's not effective on pressurized liquids or gases as well. Your application technique extinguishes fires by establishing a barrier that excludes air and oxygen. The application must enhance the formation of a surface film. Maintain a foam blanket after extinguishment to prevent reignition. Do not discharge directly into the liquid surface. You don't want to splash it around. You want to, like it says, you want to create that film formation over the surface, right? You want to have that surface film. On fires of depth, deflect the foam off the side or back or the enclosing tank so that the agent will flow down onto the liquid. On spill fires, the AFFF can be directed onto the surface just in front of the fire to spray over the fire. So you're kind of bouncing it on or rolling it on. Several items must be taken into consideration when you're attacking your Class C fires. Primary consideration is to ensure the agent is dielectric or electrically non-conductive. The equipment should be de-energized before initiating the attack if possible. Whether de-energized or not, fires involving electrical equipment can be fought with a halogenated agent, CO2, a dry chem, a water mist, or a distilled water extinguisher. Several types of extinguishers may be used when attacking Class C fires. CO2 water mist extinguishers, those are your best choices for electrical equipment. They're not conductive, they're not corrosive, they leave no residue. CO2 needs to be applied at close range, whereas your water mist stored pressure extinguishers, they can be used from as far back as 12 feet. You just got to make sure that you're actually hitting your target. The application wand and water mist extinguishers designed for operator safety. And then a halon type extinguisher. That's effective on a Class C fire. However, it's very toxic to both the operator and the environment. Dry powder agents used to extinguish Class D fires involving magnesium, sodium, and potassium. The agent limitations must be known before beginning your fire attack. Most extinguish it by caking and adhering to the material so that it excludes that oxygen that's needed for it to burn. The burning material should be covered with a 2-inch layer of the agent. It should be applied in a manner that minimally disrupts the burning material. So you're just going to want to cover over it. And then most are applied using an extinguisher or using some type of shovel. Class K are difficult to extinguish because of their tendency to reignite. Only a Class K rated extinguisher is recommended. Although properly extinguished with a dry chem, the fuel can change chemically and auto-ignite at a lower temperature. Class A, B, C, or Class B, C rated extinguishers may work effectively, but then you also have that reignition potential. Your initial attack application of the agent needs to begin about 10 to 12 feet from the burning material. Hold the wand at the edge of the flame, and then coat the surface with a side-to-side sweep. You want to continue that application until the extinguisher is completely empty. Extinguishment takes place through the removal of oxygen and then partial cooling of the fuel, so it works on two parts. The innate cooling quantity of the agent, along with its ability to go through that saponification process and create that film or that foam over there, it prevents that fuel from reaching a lower ignition temperature. All right, we're going to go through the summary. So this is a pretty quick lecture for this part. Just a lot of facts here that are thrown at you. The portable fire extinguishers have long been recognized and used as a first line of defense against your incipient fires. So they are designed for more of that incipient phase. Once it gets past that incipient phase, they're typically going to be somewhat ineffective. When your extinguishers are correctly selected and placed, inspected, maintained, and used with proper training, they have proven to save lives and property. A lot of times because you're catching it in that incipient phase, right? Before that fire begins to grow, before it starts heating up other products of combustion and having other things burn in that area. Extinguishers must be properly selected for the class of fire they are designed to combat by the personnel of the facility and the individual user. And then personnel must be alert for obsolete or damaged extinguishers so they can be removed from service before they cause injury when someone attempts to use them. That's why you have that regular inspection process from the facility itself. Individuals in a workplace, they should be trained in the basics of extinguishers so they may be able to control a fire and evacuate the premise effectively. And that's all we have for the last part of portable fire extinguishers. So that's it, and that's it for the semester. So thank you all. Hope you had a great semester, and hope you're able to take some good things away from the class. All right, thank you, everyone.